Welcome back, guys. Today my topic is projection from inclined plane. So here two types of problems you have to deal in this inclined plane. One is projection to the top of the inclined plane and from the top of the inclined plane. Means from bottom from top. So here first type is the projection from the bottom. Projection from bottom of the inclined plane. So you can see here theta is the inclination angle and alpha is the angle of projection, and u is initial velocity of the projection particle. So now the components of u and g divided u cos alpha along x-axis and u sin alpha along vertical, and along the vertical g cos theta. Here theta means this is 90 minus theta, this is also theta. So therefore g cos theta along the vertical to the incline, and along the inclination parallel to the incline g sin theta, this is ax and ay. Ay is equal to g cos theta and ax equal to g sin theta. So this is I cap and this is j cap. The minus represents directions. So here to find out the time of flight and range and maximum height and different cases. So remember that when it is reaching the projection point means range point means on the projection line some point, two things you have to remember. One is sy is equal to 0 and vy, sometimes vy is equal to 0 or vx is equal to 0. Normally hitting the inclined plane means vx is equal to 0, vy is equal to not 0. And here after reaching the point B, the sy means the vertical displacement of the projection particle is 0. So in this case, the time taken to reach this point B is called a time of flight, t seconds. So from that we will get t is equal to 2u sin alpha by g cos theta. Here theta is angle of inclination. Remember, alpha is angle of projection and it is from inclination to the projection of the projection velocity. Because all the problems and everything, however they are giving in question, so I am going with alpha and theta only. Remember this. So I have taken some example also. I will give in coming class. So now see. So this is components is clear, I think so. So now when you got t value, the AB value is equal to, AB is called here range. So the range is equal to, so you know, u cos theta, if in the only projection, in horizontal projection or in projection inclined projection with theta, not on this projection incline. In the projectile case, we studied that r equal to u cos theta, ax is equal to 0. But here ax equal to g sin theta is there, and that is minus opposite to the u cos alpha. So here u cos alpha will come along x-axis and along y-axis u sin alpha. So now u cos alpha and g sin theta are opposite. Therefore, range is equal to formula I am taking as u cos alpha into t minus of g sin theta t square. So now t take common and solve it, substitute, and finally we will get, so here 2u square sin alpha cos alpha theta by g cos square theta. So but this I am changing into, this formula I am changing into like this. R is equal to substitute t value to u sin alpha by g cos theta minus of g sin theta, means g sin theta by 2 into ay, means ax, sorry, ax of ax into t square to u 2 square u square sin square alpha by g square cos square theta, because t is equal to u sin alpha by, so u square by g cos square theta take common. So here g cos theta only there here, but here g cos square theta I am taking common. Then here cos theta will come up, and already cos alpha sin alpha is there, u square taken common, 2 sin alpha cos theta minus here g square g get cancelled means, so g went out means common, and cos square theta is also taken, remaining is here u square also taken common. Sin square alpha I can write 1 minus cos 2 alpha, because to write this formula I am using this sin square alpha, I am changing into 1 minus cos 2 alpha. You know cos 2 alpha is equal to cos square alpha minus sin square alpha. Therefore 1 minus cos 2 alpha is equal to sin square alpha will come, means 2 sin square alpha. So in the place of 2 sin square alpha, therefore 2 sin square alpha is equal to, very important in vectors and kinematics this is, and everywhere in physics, 2 sin square alpha is equal to 1 minus cos 2 alpha in integration also, because cos 2 alpha is equal to, or cos 2 theta is equal to cos square alpha minus sin square alpha, alpha plus alpha if you write means. So 1 minus cos 2 alpha is equal to 1 minus cos square alpha plus sin square alpha, that equal to 2 sin square alpha. So 2 sin square alpha I can write as 1 minus cos 2 alpha into sin theta. So now from this finally I will get the range is equal to u square by g cos square into sin 2 alpha plus theta minus sin theta. Remember this, here alpha is angle of projection, theta is angle of inclination, and if it is, you have to remember this, that's enough. And it will be projection down na, here in the place of plus minus, in the place of minus plus only will come, there is no change. The angles, so that's why this is, remember in problems also directly you can substitute this formula if you remember means, right? So actually in normal projection with theta in xy plane, the range is equal to u square sin 2 alpha by g only, but here xi is inclination angle and angle of projection. This is 2 alpha is angle of, means incident angle of velocity this is angle of projection we can tell, right? So now, so this r is maxima in horizontal projection, r is maxima at theta equal to 45 means pi by 4, but here in this case r is maximum range you will achieve when sin 2 alpha plus theta is equal to maximum, that is equal to sin value maximum and sin theta is equal to 1. Therefore sin of 2 alpha theta is equal to 1, here theta only is equal to 1. Then from that alpha value means angle of projection from the inclination should be pi by 4 minus theta by 2. So then the range is maximum. So maximum range, if you substitute this alpha value in this equation, so you will get here 2 pi by 4 means 90, and minus theta plus theta get cancelled. Therefore sin 90 minus sin theta, sin 90 is 1 minus sin theta. Therefore r maxima is equal to u square by g into, here cos square theta I can write 1 minus sin square theta. So that equal to 1 minus sin theta into 1 plus sin theta. 1 minus sin square theta, a square minus b square is equal to, therefore already above 1 minus sin theta is there, this 1 minus sin theta cancel, 1 plus sin theta, this is also you have to remember, r maxima is equal to u square by g into 1 plus sin theta. So the same thing you have to remember for downward projection also, u square by g into 1 minus sin theta will come, there I will explain. So this is about the projection of particle up of the inclined plane with inclination theta and angular projection is alpha, initial velocity e, u meter second inverse, and maximum height will substitute uy by uy square by 2g, that will be here g is equal to g cos theta and u is equal to uy is equal to u square sin square alpha by 2g cos theta. So this is maximum height. No problem is asking on maximum height, so that problems I will explain some problems. So now coming into velocity, to find out the up inclined projection, to find out the velocity. So check once, here given diagram, check once. So here theta is, so in the diagram theta is angle of inclination, alpha is angle of projection with initial velocity u, and finally velocity v, and it is in the direction as shown in the figure, and beta is the angle with origin with inclination. So therefore v cos beta along x axis and v sin beta along y axis, perpendicular direction and horizontal direction respectively. So now v cos beta means vx. The vx is equal to, according to formula, vx is equal to ux plus ax into t. Similarly, vy is equal to uy plus ay into t. The directions, because these are vectors, take as directions. So then you can substitute minus a by minus g when minus g sin theta or g cos theta or minus uy, that and all you can substitute if you have no, if you know that they are vectors, right? So now v cos beta, so that is, so here u cos alpha will be there and u sin alpha will be there here. Therefore u cos alpha minus g sin theta. Similarly v sin beta, and here means ax into t. T is equal to here t is equal to time of flight. So therefore time of flight in this case same, sy is equal to 0, that is equal to u sin alpha by g cos theta. In that no doubt at all, because theta and alpha same I have taken. So t equal to u sin alpha by g cos theta. Actually t is equal to 2u by g, 2uy by g. This is vertical projection, vertically projected body. In xy plane, that is uy, u sin theta by g, 2u sin theta by g. Here 2u cos alpha by g cos theta. Here a is equal to g cos theta and uy equal to u sin alpha. That is only different. This is in this way you have to remember 2uy by g, 2u sin theta by g. 2uy means here what? U sin alpha from the diagram, and g means acceleration g cos theta. In this case, projection body, projection above the incline. So this is a remembrance to remember three formulas: to u by g when you have to apply in the problem, and to u sin theta by g when you have to apply in the problem, to u sin alpha by g cos theta. Depends on the question, you can take these formulas. Remember. So now this T only helping in finding the range, maximum height and remaining quantities under. So first you have to find out T value whenever they have given the projectile problem. So maximum cases in projectile, in XY plane projectile, oblique projectile, there is no problem at all. It will come directly, you can substitute the formulas and all. But in this case only you have to take this question. This formula is very, very important. So now coming into otherwise, so here if you substitute means t value, you will get v sin beta is equal to u sin alpha. Otherwise you can go with this equation, vy square minus uy square minus 2g sy. Sy is 0 when t is equal time of flight. Sy is equal to 0. The time taken to complete the journey, sy is equal to 0. That is only said to be, the time is said to be time of flight. Means displacement, vertical displacement is 0. So in whatever the projection, right? So from that we can prove it. So coming into here one example problem. So in upward inclination, R maxima is equal to u square by g into 1 plus sin theta. R maxima in downward inclination is equal to u square by g into 1 minus sin theta. And for alpha value for maximum for inclination upwards, projection on inclined upwards, pi by 4 minus theta by 2. The similarly for down inclination, for maximum range, to achieve maximum range, alpha is equal to pi by 4 plus theta by 2. So now one problem here, theta is equal to given 30, alpha is equal to 40 by. You know range formula, u square by g cos square theta sin of 2 alpha plus theta minus sin theta. It is for up inclination, minus sin theta. So this you remember. So now substituting after we will get answer 2u square by 3g into root 3 minus 1. So this is. So maximum value means u square into, this will not change here. Maximum value means what? Alpha value. After substituting alpha value, u square by g into 1 plus sin theta will come 1 plus sin theta, sin of 30. Sin 30, 1 plus 1 by 2, that equals 3 by 2. 2u square by 3g. So this is example on projection on incline. So next we will see the downward projection, downward. So now here you can see So resolve the components into 2. So this is acceleration g. So this is theta. Then this is also theta. So this is 90 minus theta. Again this is theta. Therefore g cos theta and g sin theta. So acceleration due to gravity. So now Sy is equal to 0. The time taken to complete the trajectory or path projectile parabola. The time taken is called time of flight, that equal to 2u sin alpha by g cos theta. Then range is equal to, so distance traveled, s is equal to uxt plus half gt square. So here all vectors. So you can see u cos alpha, ux means u cos alpha t plus g sin theta by 2 into t square. Plus y I have taken means u cos alpha direction and g sin theta, g also same direction. So now t value substitute in this equation to u sin alpha by g cos theta. Finally we will get like this. So there we got, where in here, that is 2 sin alpha plus theta minus sin theta. But here 2 sin alpha minus theta. So here 2 sin of a minus b formula. This is 2 sin of alpha 2 sin 2 alpha minus theta plus sin theta. So there where is plus is there, here there minus will come. There minus is there means here plus will come. That is only different. That is the reason I am telling you have to remember this formula, u square by g cos square theta into sin of 2 plus or minus 2 alpha plus or minus theta plus or minus sin theta. When plus, when minus, you know theta. So now, so you know this formula. So for this is for incline upwards from bottom to up of the inclined plane. So this is the formula for downward direction. So now some problems you'll see on this concept. So what should be the ball be projected above the inclined plane with a velocity u, so that it may hit the plane normally hitting. That means Vx is equal to 0. So plane normal hitting means Vx is equal to 0. So Vx equal to ux plus ax into t is equal to 0. So substitute here in above the inclined plane, ux is means u is upward direction, a is downward direction, ax is downward direction, therefore minus, both are opposite direction. Substituting means you will get tan alpha is equal to 1 by 2 into tan theta. In some of the authors they will write tan alpha equal to 1 by 2 into tan beta. Otherwise tan beta is equal to 1 by 2 tan alpha. That is, you can no need to confuse theta alpha. Theta alpha only will follow everywhere. Theta means angle of inclination, alpha is angle of projection. So that is upward projection or downward projection. So now see here, and this is a very important. Normally it means Vx is equal to 0 in this case. And in finding the maximum height and all, Vy is equal to 0 will take in oblique projection at maximum height. Time of ascent, time of descent there. So here normally hitting the inclined plane means Vx is equal to 0. That you find out. Remember that. So next question, see here. So 30 degrees is theta and 60 degrees is, and total angle 60 degrees is given. Therefore alpha is equal to 30 take angular projection. Some of the problems they will give like that. Theta is from whole angle from the origin they will give horizontal. 60 degrees beta is the 60 degrees with horizontal. So I have to convert into alpha, because I remember sine of 2 alpha plus or minus theta plus or minus sin theta for that purpose, right? So now here substitute the given values. Theta value, alpha value is 30, theta value is sub 30, and u value is equal to 21 meter second inverse according to this question. Here firing from the bottom, where it will be hit the target. So or where it will fall, that equal 30 meters. After substituting the values, you will get 30 meters. Similarly, next problem. So see here, given problem is u is equal to 5 meter second inverse. So here u is equal to 5 meter second inverse. Theta is 30 and here beta is equal to 30 is given. So here theta is 30, this is origin, therefore here, so this total is alpha, here angle is also 30 will come. Therefore alpha will become 60 here. So in this case alpha will become what? 60 degrees. So now substitute the values, the range value, range equation is equal to u square by g cos square theta into sine of, it is downward inclination 2 alpha minus theta plus sine theta. Okay, that equal to u square value, u is equal to 5 is given, substituting means 5 meter. This is the correct answer. So now beta is equal to 120. That means now it is above the incline is projecting. So here I have given diagram. This beta is changed like this 120 degrees. So this is 120 from beta is 120 with origin 120 degrees. So then the total beta angle is 30. Here alpha is equal to become 30. Here theta is 30. Here also theta is 30. Total 150 gone means plane angle is 180. Therefore 30 degrees here. Therefore alpha will become 30 now. So now substitute alpha equal 30 means you know range formula. Range is equal to u square by g cos square theta. Theta is angle of inclination. Sine of 2 into sine of 2 alpha plus theta. 2 alpha. Here alpha equal 30. 60 plus 30 90. Sine 91. 1 minus 1 by 2. 1 by 2. Therefore 5 by 3 meters. So these are the problems related to down inclined plane, up inclined plane and the projection from the above the inclined plane. And actually the oblique projection I have to start, but that and all easy there. So if people can understand, we need to explain that concept. That is the reason I have taken here, and I have given comparison here how to compare those questions and all. Yes. So guys, thank you all. Thank you, ma. Thank you.